Hi guys, so hopefully you've finished trying this practice question. I'm just going to go through each question step by step. So let's start with question 3a. Okay, so the question says there are 3 unlabeled bottles which have different colorless solutions. We know that one of them is hydrochloric acid, the other is sodium chloride, and the other is sodium hydroxide. All 3 are colorless solutions, and we don't know, if you're just looking at it, we don't know which one's which. So, and then they say, these unlabeled solutions can be identified by using red litmus paper and baking soda. So red litmus paper and baking soda. Okay, so we know that hydrochloric acid is an acid, sodium hydroxide is a base, sodium chloride is a salt. Salt is neutral, so it's neither acidic or basic. Okay, so we need to complete the table first. So let's start with the red litmus paper. Okay, so if we put a red litmus paper into hydrochloric acid, it's just going to stay red. And then if we put a red litmus paper into the solution of sodium chloride, which is neutral, it'll stay red. But if we put it in sodium hydroxide, which is a base, it'll turn blue. Okay, so that's done. What about baking soda? So look at the chemical formula. Sodium hydrogen carbonate. That is a base. Okay, it's a base. So we talked about different types of bases. Hydroxides, oxides, carbonates, and hydrogen carbonates. So when hydrochloric acid reacts with the baking soda, it's going to undergo neutralization reaction. And remember, every neutralization reaction forms metal salt, water, but when we use a base that is carbonate or hydrogen carbonate, it also produces carbon dioxide gas. And we see that as bubbles forming in the solution or fizzing. So I'll write bubbles. So that's what we're going to observe when we add baking soda and hydrochloric acid together. Now, if I put baking soda and sodium chloride together, you're not really going to observe any bubbles because baking soda and sodium chloride don't react together. So I'll just put no reaction. And sodium hydroxide and baking soda, both are bases, there's no reaction. Okay, so we have done the table. Okay, now question 3a2 is asking us to explain how the observations allow us to identify each solution. So how the observations. And then we also need to give reasons for any changes or reactions occurring. So what that means is you need to give reasons for the observations that we are seeing. So let's start answering the question. Okay, so let's start with red litmus paper. So we know that red litmus paper turns blue when it in a base. Correct? Now, in the 3 unlabeled solutions, there is only one base, which is sodium hydroxide. So the solution that turns the red litmus to blue must be sodium hydroxide. The other two solutions will just stay red. And that's not really helpful because we still have two solutions that we haven't differentiated yet. But we can move on to baking soda. Okay, so we could start that, when sodium bicarb or baking soda reacts with hydrochloric acid, it forms carbon dioxide gas as one of the products. Therefore, bubbles or fizzing will be observed. But then now we also need to explain what happens when baking soda is put with sodium chloride. Okay. However, sodium hydrogen carbonate does not react with sodium chloride, so no bubbles will be observed. And then we can conclude that therefore the solution that shows bubbles when baking soda is added must be hydrochloric acid. The remaining solution must be sodium chloride. So this is what I would write for this question. So remember, you need to explain your observations. Why does the red litmus turn blue? Because when red litmus touches the base, it turns blue. Why do we see bubbles, which is our observation? Because when acid reacts with a base that is a carbonate, it forms carbon dioxide as its product. Why don't we see any reaction with sodium chloride and baking soda together? Because they don't react. Therefore, no bubbles will be observed. Okay, so let's move on to the next question. Question B. So in this investigation, copper sulfate will be made by reacting solid copper carbonate with sulfuric acid. And they've kindly given you the name and the chemical formula of the acid. When I have questions like this, I like to always figure out the chemical formula. So copper sulfate. So copper is 2+, sulfate is 2-. Therefore, the chemical formula is CuSO4. Copper carbonate, Cu2+. Carbonate is CO3 2-. Therefore, the chemical formula is CuCO3. And we already know the chemical formula of sulfuric acid. Now, the first question is asking you, name the type of reaction occurring. So if you read the question, the reactants are sulfuric acid, which is an acid, and it reacts with copper carbonate. Again, a carbonate is a type of base. So when an acid and a base reacts together, they undergo neutralization. Okay, and the second question is to write the word and a balance symbol equation for this reaction. Okay, easy. We know how to write the word equation. It's already given to us. So the reactants are sulfuric acid plus copper carbonate and arrow, and it forms copper sulfate. If this is where you stop, you won't get a mark, because a neutralization reaction also forms two other products. Water, and please don't write H2O because that is not a word, it's a symbol. And also write carbon dioxide. Why? Because the base we're using is a carbonate. And now we need to look at the balance symbol equation. Oh, there it is. Okay, so sulfuric acid, we already know, H2SO4 plus copper carbonate, 3, and then copper sulfate, CuSO4 plus water plus carbon dioxide. Now we don't know if it's balanced yet, so I always like to use a table. Reactant and product. Okay, and I need to write the type, all the type of atoms that I have. Hydrogen, sulfur, oxygen, copper, and carbon. Cool. Now on the reactant side I have 2 hydrogens, 1 sulfur, 7 oxygen, 1 copper, and 1 carbon. On the product side I have 2 hydrogens, 1 sulfur, 7 oxygens. Oh, this is looking promising. 1 copper and 1 carbon. Voila, this is already balanced. So you don't need to do anything to this equation. And then we can move on to question 3. Now, this question is asking you, describe how you could make solid copper sulfate crystals. So that is the metal salt that we're forming. In your answer, you need to include how you would know that the reaction had been completed. If they ask, if they add a sentence, an extra sentence asking you to do something, then do it. So let's start the answer with how we would actually do or form copper sulfate. So to form this, we know that we have to add sulfuric acid and copper carbonate together. To form copper sulfate, water, and carbon dioxide. And then we could say we would know that the reaction is complete when, so we can say, so there are 2 options. Okay. When when the bubbles stop being produced, or when there is no more fizzing, and that's saying there is no more products being formed, and that indicates that either one of the reactants or both reactants have been used up. Or you could use a universal indicator. Using pH indicator to see if the solution, the reaction, is pH of 7, right? If it is, then there is no more acid or base. All you have is the neutral water and neutral copper sulfate. That means that the neutralization reaction has been complete. Okay, so cool, we've covered the extra sentence. Now, if this is where you're going to leave or end your answer, you won't be getting your excellence mark. I know you did mention, how to form copper sulfate, but the question is specifically asking you, how can you make solid copper sulfate crystals? Remember another product of this reaction is water, and copper sulfate dissolves in water. So you're not going to be getting solid copper sulfate crystals. So you need to write heat the reaction mixture to evaporate water so that only solid copper sulfate crystal remains. And then you can get your excellence. Okay, so let's go to the marking scheme. So this is the marking schedule for this question. So check your answers by comparing to the evidence. Now if you look at the achievement, if you get one row of table correct, so if you get one row, that's one achieved. Or if you didn't get any of the rows right, but you got one of the columns right, then that also gives you one achieved. And then if you give me one reason for your if you give me a reason, if you give me a reason for one observation, for example, litmus paper turning blue because sodium hydroxide is a base, then it'll give you one achieved mark. So here you can get in total 2 achieved. You can't get a merit point from the table, but you can from the from question 2 here. You can do that if you complete the table correctly with one observation explained, or if you get 2 observations explained. So in total you can get 1 merit point, okay, because it's your or. And for excellence, you need to explain correctly to identify. You need to provide explanations for all the observations. And that'll give you 1 excellence mark. Now, the other questions. So if you get the neutralization reaction part right, that is 1 achieved. That's 1 achieved. If you get correct word equation, or if you get the reactant formula correct, or if you get one product formula correct, then that's 1 achieved. If you get, if you say that the observations, so if one of the questions was, how would you know when the reaction would stop? If you say, either the bubbles would stop fizzing or the pH of 7 has been reached, that gives you 1 achieved. And then if you say that, evaporate the water to get the crystals, then that's also another achieved. For merit, if you have the correct formula for a simple equation, that's 1 merit. If you explain why the reaction would be completed when no more bubbles are produced, or that the reaction would be completed when the pH is 7, that also gives you 1 merit. And if you say, if you explain how to get the solid or crystal copper sulfate, then that's also 1 merit point that you can get. For an excellence, you need to fully explain how copper sulfate can be made from copper carbonate, sulfuric acid, and you also need to include when the reaction would be completed. And you really need to explain that evaporation needs to happen to leave behind the copper sulfate solids. So if you do that, that's an excellence. So for this question, if you get 2 excellence points, that's an E8, 1 excellence point, E7, 3 merit points, okay, doesn't matter if you get, 2 merits and 1 excellence. If you get like 4 merit points, it doesn't matter if you get 4 merit points, you won't be getting E7 because you don't have any excellence point. So 3 merit points will give you M6, 2 merit points M5, 4 achievement points A4, 3 achievement points A3, and below that you will get not achieved. Okay, so that was it. I will post this on OLE. And if you have any questions about this, please let me know. And tomorrow we'll be going over the homework sheet that we did on like ion formation and ionic compound and ratio. Okay. Well, thanks for listening, guys.